Okay, so this next part, we're still in 4.2. All right, but now we're going to work on evaluating logarithms. All right, the whole point of this is being able to say, well, what is that power, right? What happens if it's an unknown power, like we have here, where I don't know what power I take 10 to get 10,000, or we may know it, but let's pretend we don't. All right, or I don't know what to take e2 to get 15. Again, we may know it, but let's pretend we don't. All right, and with these, we call these our special bases, all right, because these are the ones that we're going to use quite often. These are the ones our calculators can actually handle. So that's why these are awesome and special. Calculators help us. All right, so 10 to the blank power equals 10,000. You may know this is x is 4. If you don't know, we'll see why. All right, if I were to write this as a log base 10 of 10,000 equals x, this piece here, log base 10 of 10,000, our calculator can handle. If you look in your calculator, it's just the LOG button. All right, that's what we call our common log, log of 10,000. You plug that in your calculator, you're going to get 4. All right, similarly, we can do that with e to the x. All right, e to the x, if I were to switch this to logarithmic form, it would be written as log base e of 15 equals x. So it's saying, what do I take e2 to get 15? It's this x number. All right, and this is another special logarithm that we write as called the natural log, and we use ln of 15 equals x. And again, your calculator can do this, and these two buttons are right under this second button, so you'd hit ln of 15, and we get an approximation. X is approximately 2.708. Okay, and that is what the natural log of 15 is. It's just a constant. All right, so we can do all these problems. I'm going to have you try them. Right, so log of 45, type that in your calculator, you get 1.653. Natural log of 35 is 3.555. All right, and you can get approximations, some actual numbers, and what these are saying are, if I take 10 to the 1.653, it's going to be approximately 45. All right, same thing with e to the 3.555, it'll be approximately 35. All right, so what I want you to do now is try these next three. I'll post an answer key to this so you can check your answers later, but I'm not going to put them on this video here. And what we're going to do is move on down to how to evaluate some of these without a calculator. So when you don't have a calculator, something like this, log base 3 of 27, right? We don't have a calculator that can do this because it's not a log base 10 or a log base e. So our main method is going to be what I call, it might not be the actual word to use, but I call exponentiating. All right, and what that does is switches it to exponential form. All right, so I'm going to use that swirl method. I'm going to take 3 to the x equals 27. And then I'm going to hope, and it will be if I'm asking you to do it without a calculator, I'm going to hope it's a power that I know, right? I know, just from looking at different powers, I know that 3 to the third equals 27. So in this case, x equals 3. Right, and I can continue this with all these. If I don't have a base 10 or a base e, which I don't in any of these cases, I have a base 2, 5, and 4. What I can do is exponentiate them. All right, I'll do this first one with us. All right, I'm going to set them equal to x, swirl, so I get 2 to the x equals 16. And then I use what I know 2 to the 4th equals 16, so x equals 4. Again, I'm going to leave these other problems for you to answer, all right? But there will be an answer key for us. One thing I will say is this very last one, you can use your calculator for, number 4. I kind of skipped over it, but you can use your calculator here if you want to, but try and do the swirling, right? Because if we don't have a base listed, it's base 10. All right, down below, we have some basic exponential properties. All right, these are not huge things, but these are just explaining how they can undo each other. Right, so this first one saying log base b of b equals 1 is because b to the first power is equal to itself. Log base b of 1 equals 0. This will be true for all bases but 0. All right, is because if I swirl this, I get b to the 0th equals 1, which again, anything to the 0th power but 0, so in this case b can't equal 0, is going to be 1. All right, over here, this is the inverse properties that we've been talking about. Right, this is what we're going to do later on to solve some exponential equations. But if I take log base b of b to the x, these two things undo each other, and I just get x left over. And vice versa, if I take b to the log base b of x equals x, it again will undo it. This last one requires that x be greater than 0, because we're going to see that our domain of a logarithm is actually all positive numbers.